So today and Thursday we're going to carry on looking at SQL. This is SQL2, the Revenge. And we are going to carry on looking at SQL. We're going to look over the next couple of days at more data operations. I've done what I did last week, so we just have one lecture that we'll carry on Thursday and Friday. At some point we'll dwindle out today and we'll carry on Thursday and look at examples. Before we start, I've been asked by PJ, one of the class reps, just to remind you there is an open survey. It was in your email, available to complete a SurveyMonkey survey to judge me and find me wanting. But the class reps do a great job. Their job is to flag up any issues, any concerns, anything that you don't want to talk to me directly about, or anything that you think we could improve or do better. So I encourage you to find that in your emails, go through and fill it out. And they've said basically the last day is today is the last day to complete it. So if you could complete it, that would be good, and then give them an idea of how it's going on, what you think, and they will come and tell me what's going on, and also take any issues to the Staff Student Consultative Committee. So that's quite a useful thing to do. So in this lecture, as I said, we're going to cover some more parts of SQL. We're still looking at the data parts. We're going to look at insert, update, and delete. It would help if I plugged that in, wouldn't it? No? Oh, come on. Right, okay. And use today's meet if you have any questions that you want to ask. Hey, okay. Just to quickly come back to something we talked about. So the week 7 class test is going to be design focused. Just a reminder, the lectures that apply to it are the ones from week 1 and week 3. So lectures 1, 2, 3, 6 and 7. And the practicals that it relates to are the first and the second practical. So practicals 1 and 2 that happened in weeks 2 and 4. All of the other stuff and that is potentially usable in the assignment and will potentially be examinable. But for this class test, it will be a paper-based test and it will be on the design elements. I will expect it to be something like the first and second practicals. There's a mistake there, isn't there? It's not practical 1 and 2, it's practicals 1 and 3. Because practical, the second week's practical was, it was set theory and stuff, wasn't it? Yeah, no, so it's whatever. I said this before, so it's practicals 1 and 3, it's the design things, okay? So, let me tell you what the sort will be. The first bit will almost certainly be, here is a textual description of a business. I want you to go through and identify the entities and do some entity mapping. So that will be like the first week's exercise. You will definitely also, nothing's working out, is it? Oh, it's turned off. Give me a second. There's a sign. Right. So, yeah, okay, there we go. Luckily, I'm not superstitious, eh? Start talking about the assignment. This thing reaches down and breaks the radio signal. Let's try that again. The assignments, the first part will be a entity mapping. So probably some textual description, identify the entities, map them into it. We will also be doing some normalization. There'll be some AR diagrams, and there'll be some data types. So it will basically be what you've done in the practicals in terms of design. So entity relation mapping, what are the entities, how do they work, how do they relate to each other, a few questions about that, potentially a few different scenarios for you to map. Here's a schema, basically probably a form, like you've seen in the other ones in UNF, take it through to first, second, third normal form, possibly a couple of those, and then some questions about data types and things like that. So that will be in the week 7 class test. Right, so let's carry on then looking at SQL. Quick reminder of what SQL is in case you've forgotten since Thursday. SQL is a domain-specific language written specifically to interact with relational databases, RDBMSs. It's very similar to and based on a thing called Alpha, which was invented by a guy called Edgar Codd, who is the database guy in terms of relational databases, basically invented them. but it's a slightly different version, and it's a standard that's used and designed to be sort of human readable. There's a few different scopes to what SQL does. So data query is quite probably the largest thing that we do. We exploit existing databases. That is the select. So we spent last week looking at that. Data manipulation is what we're going to look at this week. So inserting, updating, and deleting. And then we move on next week to looking at data definitions, a schema definition. How do we use SQL to actually write databases? We can use tools. We had a look last Thursday at PHPMyAdmin. So I can create a database in that. I can go create a database, and it will give me how many columns do you have, what are the types, and it will generate the SQL for me. It will make it. That's fine, but it's also quite important for you to understand SQL as what's called a DDL, or a data definition language. So how do we actually create schemas in SQL itself? So yeah, we've had a look at query, and we're now moving on to have a look at manipulation or updates. And here's some examples then of queries that we've been through a few times, and we'll now explain what's in all of those. So we have our schema, we have our database created. We have our tables, and each of our tables has columns, and they are of certain types, and we've populated it with data of our pets or our students or whatever. And we now need to add more data to it. So we add data to tables using the insert verb, the insert keyword. And the format of it is fairly straightforward. Insert into table, bracket fields, values, brackets, values. So insert into, where are we going to put it? Which table are we going to operate on? So exactly like we do select from table, insert into table. So what's the entity? What's the table that we're going to insert into? What are the fields? What are the columns that we want to insert data into? We don't always want to insert all the data all of the time. We'll come on to this in a minute. We often have missing data, partial data. When I create a new customer record, I might need to know a name and a phone number, but I wouldn't necessarily know address, fax, mobile, all of these other bits of information. So what are the fields, what are the columns that we want to actually insert now into the record and update? And then what are the values that we want to put into those columns? And the general form of it then is this. So we're saying insert into table, list of fields, and then a list of values. And the values map to the fields. So field 1, we put in there whatever's in value 1, field 2, whatever's in value 2, and so on and so forth. So we just list, insert into this table, here are the columns, and here is the data that we want to actually put into there. So we'll be using our usual sort of pet example for SQL examples, where we ask a question, a query, and then you'll have a look at the output. So that's the kind of way we'll go through it. So we have our pet table. We already have some details in there. And the first thing we want to do is we want to add a new pet. So how can we add a new pet? We want to call it Dogtanian. It's a dog. Its breed is Beagle, and it's 6 years old. So we have now pretty obviously what we want to insert in there in terms of data. We know what columns, name, type, breed, age that we have, and we also know what the values of those are going to be. So this would be our SQL query then. So insert into the table, so insert into pet, open brackets, let's list the columns. So we're going to add name, type, breed, and age, and in that order. And then values, and then the values, unsurprisingly, that we want to put in for name, type, breed, and age. So that is the sort of fundamental insert query. Insert into table, this field, that field, values, this value, that value, and map them between. So when we do that and we execute it, if we have a look at our table, now the contents of it, you'll see that at the end, Dogtanian has been added. It's a dog, it's a beagle, an age of 6, so the data has been added in. You might notice that we didn't give it a pet ID. When we inserted data into the table, we didn't actually give a new pet ID, and some of you may already know why that is. We had a look at that. I think in your practical you were asked to have a look at a few different field types and get it, is that the pet ID is we've set to what what's called an auto-incremental key. So we don't need to worry every time we insert a new record, the database handles for us, adding one on and putting it in. So we don't need to worry about giving it a pet ID or a unique identifier. And we'll come on when we look at schemas exactly how we define those and how we set fields to be auto-incrementing. But here we go. So, okay, insert into table, this column, that column, values, this, that. That's it. That's the simplest form of insert as we go. So we might ask ourselves Another thing, I don't know why that, okay, that's excellent, my animations have failed, that's come up before. So how can we add a pet we found? We've called him Harry, but we don't know anything else about him. So now we're inserting into pets, name, values Harry. All we know is the name, so that's an example there. We're not listing the other columns. We're literally just inserting a pet, name is Harry. And what happens is what you see on the table there, that a pet's been added. The ID has been auto-generated, 109. It's automatically incremented. The name is what we've set, but everything else is either blank or default. So type is blank because we didn't put anything in. Breed is null because we've set that as a nullable field, so it literally contains nothing. And the age is a number. We didn't provide a number, so it's defaulted to 0. So it's inserted that and it's done it. But the question really is, should we or would we allow that to happen? Should we allow an insertion of a record into our database of a pet where we don't know what it is, what breed it is, and what age it is? We might do, but we might not do. But that's a decision we'll make. And we come back to it later on, that when we do schema design, one of the things that we concern ourselves with, if you remember from our data dictionary, is a field required, yes or no? So when I put this schema together, I did not put any of these fields as being required, so therefore there's no error. But we can have the database say no and reject records that lack certain values, and we'll see that later. But for the moment, we insert into pet name, values Harry, and it just pops up and goes down at the bottom. Oh, okay. So in terms of inserting data, partial data, we can get away with, and what we can get away with missing and not putting in is defined by the schema. We define it when we create the database. What do we need? What do we get away with? What's required? What's not required? And we can also, if we say, okay, this field isn't really required, we can determine what happens if it's not provided. So we could say, it's fine, it's okay to be blank. If this field isn't provided, it's a blank string, it's an empty string. We can say it's okay to be null. Null is a special thing. It means it's not even a blank string. It's literally a black hole. You know, there's no data contained within it. Or we can provide a default. We can say, in the event that this string or this value isn't provided, the default is fish or something like that, or number 6 or whatever it is that we want to put into it. So we can define when we create the schema, is this field required? If it's not required, we're not going to give an error if it's not provided. What happens when it's not provided? You will see some alternative versions of insert. And I'm denied about putting this in because it might muddy the waters slightly, but I think you'll see them in SQL examples, so I think it's very much worthwhile having a look at it. So the version of insert I showed you was insert into table, brackets, field, 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 close brackets, value, 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 value. You don't have to specify the fields. An alternative format of insert is insert into table, values. We give no field names, but it means that we must firstly give a value for every single field in the table, and secondly give them in the same order that they're created in the table. So if I know definitely that my table has 4 fields and I know the order they're in and I know exactly what they are, I can just say insert into table, brackets, value, 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 value. The downside of this method is that it's very, very liable to break horribly later on. So you write it now and you write your insert statements because the table has 5 fields and you know the order they're in and everything's fine, but at some point in the future, someone comes along and adds another field to the table. You've added a new bit of data, you've added something there. That will then break all your existing code, you get a regression error, and suddenly all of your insert statements and everything fail to work. So it's certainly best practice to always specify the fields. It's always a good idea to be as explicit as you can in computer science generally. When we create variable types, we are very explicit on what they are. When we want to send data to a file, we don't want to be arbitrary, we don't want the system to make its mind up, we are very exacting. And we should be as well when we do SQL schemas. It is very commonly used for mass inserts. So if any of you had a look, you were doing the practical, you saw the Northwind SQL database, some of you might have had a look at that and actually had a look at the raw SQL that created it. And what you probably see in there is that it creates the table and then just does a lot of inserts without specifying the fields. Well, that's fine because it has just created the table. So it knows, it's a dump, it knows what the values are. But generally speaking, you'll see this format, you'll see some people online who just say, oh yeah, use this format. Don't. Always be explicit and specify the names of the columns in there because it avoids future error and removes any doubt or ambiguity. So that's it really, that's insert. Insert, dead easy. Insert into table, these columns, these values. That simple. Adds new data and comes in. Insert either works or it doesn't. There's no kind of wheres, there's no matching, there's no wheres and wherefores. If I insert data and it meets the criteria, it meets the constraints of my schema, the fields that I need to exist, exist. Any foreign keys that exist, exist. If I insert an order and it has a customer number in it and I've set the database up so that customer number refers to the customer table, if there's a customer of that number and all these kind of things, all the constraints are met and the record is inserted. If it goes wrong, if the data types don't match, it's incompatible, you're trying to insert a duplicate key because you have specified a pet ID that exists already, you fail a constraint on this, and the server returns a horrible error and the data is not inserted. So it either works or it doesn't. It's quite a binary process like that. So we've inserted data into the database. We have our rows, we have our records, we know how to add new ones. The next question is, how do we update the ones that we've got? How do we make changes to data that's within it? And confusingly, or non-confusingly rather, the verb we use to do that, the instruction, the keyword is update. So the syntax here, again, designed to be human readable, hopefully easy enough and friendly enough to understand. Update table, set field equals value. We might have fields, different fields and values. It's a comma separated list, as you'll see in a minute. And then an optional where query. So update this, set this column to match this, where something or other is true. So the where category, and we'll use where in updates and deletions, is the same syntax, exactly the same clause as you use in select. It's exactly the same, it's a logic predicate. We are saying update these rows in the table, update these database records where this condition is met, where they match this particular rule. So update the table. What is it? What is the entity, the table that we're going to update? What are we operating on? Set field equals value. So what fields or what columns are we going to change and what value are we going to change them to? Update balances set credit equals 0. Go through, choose a table and update it. And then what is the optional condition as to which rows we change? If I change my name to something cool, like Ezekiel, that I was almost called apparently when I was born, the query to update me in the staff records would say update staff, set name equals Ezekiel. If I just ran that on its own, it would update everybody's name to Ezekiel. So in the same way that when we're selecting we need to limit the rows that come out, we would then say where staff ID equals and give my staff ID number. So we limit the changes that are made. We generally only want to update 1 or 2 or 3 records. If someone wants to change their password in the database, I want to update you with a new password, but I only want to update your record. All right, so we use the where query to specify which of the rows it is that we update. So let's have a look at a couple of examples. So we've entered Harry into our database and we're lacking data on him. So let's try and set pet 109, who is Harry. And he is actually a parrot, we've discovered. Parrot is a type of bird. And he's 50, because we asked him and he told us, because they do that. So here's the query. Fairly straightforward according to the rules. Update pet, we're updating the pet table. Set type equals bird, comma, breed equals parrot, comma, age equals 50. So here are the columns that we're setting. Set this column to that value, this column to that value, this column to that value, where bird ID equals, or pet ID equals 109. So update this table, update these columns to these values, but only where this condition is met. In this case, only where pet ID equals 109. And when we run that query, two things should happen. Firstly, in MySQL admin, PHP-MyAdmin, we see a nice green update that comes up at the bottom. It's always quite useful and reassuring. It will tell us how many rows were affected. So we've run a query, we've run a change on the database, how many rows were affected or changed by that. And then secondly, the other thing that happens is the actual table updates. So here's a select star from pet, and you can see that good old Harry at the bottom, pet number 109, has now got that additional data added to him. So in this query, we've been doing pet ID equals 109. And you might wonder why we said where pet ID equals 109 and not just where name equals Harry. We've only got a pet, we've called him Harry. Why don't we just say update where name equals Harry? So to go back to what we were talking about a few weeks ago in terms of keys, pet ID here is the primary key. So you'll remember that a primary key is a unique way to reference the specific instance of an entity. We have lots of pets. We can have several pets called Harry, just to be really confusing. But we'll only ever have one pet with an ID of 109. We'll only ever have one staff member with a staff number of mine, only ever have one student with your student number, but we might have other staff members called David Cutting, Bob Smith, or whatever. So that's why we have the primary key, and why when we operate on the table, it's best practice to always be explicit on the record that we want. Don't say where name equals Harry, oh, and type is parrot, and this and that. If we know the record we're after, if we know the row we're after, we've got its unique ID, operate on a unique ID. Change it where pet ID equals 109, job is done, and there's no risk that it's ever going to get changed. And the pet ID, the primary key, will always be unique. So what happens if we forget our where clause? What happens when we do a select and we don't put a where clause in? When we do a select and we select star from pet with no where clause, the simple thing is all of the records match, all of the rows match, and we get all of the rows come out the other end. So the same thing happens when we use where clauses to limit in terms of updates, and as you'll see a bit later, in terms of deletes. So here we go, here's our pet table back again, and what I really want to do is I want to add 1 to all the ages of my pets. I'm a bit weird, all my pets were born on the same day. That's why I take them as pets. That's the day I steal my pets every year. And so on the lucky day, I need to increment all of their ages by 1, so I want to do every single pet. I could, as you've seen before, I could go through and add 1 to every single pet individually, but really I want to do that in a single query. So here we are, update pet, set age. Obviously we are setting the age. And what are we going to set it to? We don't want to set it to a numeric value, we want to set it to a relative value. So update pet, set age equals age plus 1. So take the current age, add 1 to it, and again from your Java, and Angela's just sort of left, you should recognize that makes sense. If I have an integer called age and it's 6, and I say age equals age plus 1, it will then be 7. It will take the earlier value, add 1 to it, and then evaluate it back into the stack. So update pet, so age equals age plus 1. We run that, we get a nice green box, 10 rows affected, we have 10 pets, all of them were affected, everything was changed, and all of our pets are now a year older, a year wiser. So that's what happens when we don't put where clauses in. Any time where we can put a where clause to limit either the data we get out, the data that's affected, what rows match, if we put nothing in, it's the equivalent of writing where 1, where it's true, and every single row will match. So in this case, the update would apply to every single row as it runs. Another example is Bob the turtle. We have no idea what his breed is. He's pet ID 102. And what I want to do is I want to update the database, I want to update the breed to unknown wherever it's blank. Now the question I'm asking is not how do I update Bob or pet ID 102 to have an unknown breed. It's go through and anywhere it's blank, I want you to update it to be unknown. So here we go, fairly straightforward query. Update pet, set breed equals unknown. What's the where clause on that? Where breed equals quotes, quotes. So exactly the same. If I said to you, I want you to select a list of all of the pets who have an empty breed, select star from pet where breed equals quotes, quotes. As I say, the where clause it uses exactly the same. It's literally the same thing. So here we are, update pet, set breed equals unknown, where breed equals quotes, quotes. And then when we select that back out, Lucky Bob is now an unknown type of turtle rather than a blank type of turtle. One of the things you may have noticed, obviously, I'm sure you have, is that sometimes I use quotes around stuff and sometimes I don't. So we use quotes around contextual and textual values. So when I want to insert something into a character field, a text array, I want to insert some text, I will always encompass it in quotes. Even if there's no spaces in the string, I will always quote it. If you don't, it will attempt to evaluate it as a constant or a numerical value, and it will error. It will say you have an error in your SQL. So whenever we're dealing with textual data, we insert quotes around it. Single or double quotes are usually fine. Usually fine. I say usually because I think they probably are fine, but there's bound to be some database engines that insist on doubles or singles or whatever. So it's whatever the standard is. And you can use singles or doubles, but you mustn't mix them. You can't open a double and close with a single. In MySQL, numerical values can also be quoted. So what you can do is, if in doubt when you're writing your program, is you just quote everything. Quote every single thing that goes into it. 18 is fine if it's a numerical field, either in quotes or outside of quotes. But as I say, if you quote them, it doesn't really make any difference. Sometimes, though, we will want to put quotes into the actual data itself. In the same way in which in Java, sometimes we will want to print quotes out from a string that is itself quoted. So we want to insert quotes into them. And very much like most programming languages, we use what's called an escape character. And in MySQL, it's a backslash. In some other servers, it's another quote. Microsoft have this weird convention where a double quotes is a double quotes, but two double quotes are an escape double quotes, but they have serious issues. And so here what we do is, if we want to insert a quote, we want to put it in, we insert a backslash in front of it and put it in. Now, I mentioned briefly in the question, very, very good question that came over about SQL injection and how that works. And we are going to come back and look at security in case. But this is fundamentally the bones and the cause of SQL injection errors. Okay, so an SQL injection is where I have a web service, a website, some system, and you maliciously are able to execute bad SQL against it. Right? So I have a form, I have a web page. It takes a username and a password. It loads them up. And it does a query where it says select from user, where username equals the username you've entered and password equals the password you've entered. That is pretty common, and that's the way most web things work. They check your account details against the database to make sure you're on file. So it takes your input and it puts it into an SQL statement. It builds this SQL statement saying select from user where username equals this and password equals that, and this and that are values that you have typed in. Lovely. And that works fine until someone types in a username of close quote, semicolon, drop from students. What happens then is that SQL comes along, SQL tries to execute it, we build the quotes, and the query becomes incredibly complicated. The query becomes select from user where username equals quote, close quote, semicolon, to end of statement, another statement that's executed, semicolon, and then another part of data. So if we don't sanitize the input, if we don't control what the users put in, if we just trust what they type in will be a safe string and just put it straight into our SQL, there's a very real possibility that hackers will be able to exploit it. And SQL injections are incredibly common. I've done quite a lot of my consultancy work over the years in fixing this kind of things. There are toolkits available to scan for SQL injections, and these aren't elite hackers that are coming up with them. These are script kiddies and those kind of things that will literally be able to run stuff. So not elite computer scientists like you. You can run them and you can find it. But what it allows you to do, and as I say, I'm just mentioning it now because someone asked the question, and the quotes are relevant because we need to protect what comes in with quotes and escape them. We are going to have a good look at SQL injection security later on with some better examples of how it works. But one of the things that is staggering is the volume of websites out there that still have SQL injection vulnerabilities. They still have them out there. So I think the Ashley Madison hack, that sort of affair website that got hacked, that was almost certainly an SQL injection vulnerability, allowed people to log in as an admin user. People are often finding official government sites, things like that, that have SQL injection vulnerabilities. So if we just trust the user input and we execute it against our database, it's fine until someone puts something bad in. So SQL injection is injecting structured query language into places it shouldn't be, and we protect against it by sanitizing input. And one of the ways we do that is escaping all of the quotes and everything that comes in. So even if I write something bad, it doesn't matter. It just gets stored in the database as if it was data. But we'll come back and have a look at that in detail later on. So that's why we quote data. One of the other things we'll often want to quote is we want to quote schema items. So there's a lot of keywords in SQL, and they vary between different databases. So, but certainly insert, date, update, all of these kind of things are protected keywords in SQL. So if I want to have a table called update, where I log all of the updates that are made, by default, SQL will have a hissy fit because I'm trying to execute things that have reserved keywords in there. So we often want to quote schema items. We don't use normal quotes for this. We use the little tick box, which is on the top left of a normal keyboard, and the bottom left by shift of a weird Mac keyboard. So we use the little back tick to go in. I don't know why that's a convention, it just is, but we can escape fields, we can escape tables, we can escape names, and what you'll find is if you use phpMyAdmin to do like an export or a dump, it automatically escapes everything with all these little backticks. They're absolutely everywhere. Personally, in terms of you writing SQL, you only need to do them when you run it and something doesn't work because it doesn't like the field name, or it doesn't like the column name, or it doesn't like the table name. So that's how we escape values like that to put into it. So that's quotes. So the final thing that we want to do, so we have now, we know how to read data, we know how to insert data, we know how to update data. Finally, how do we delete it? How do we tell the database that I've had enough of this, I want you to remove rows from the database? How do you do that in terms of deleting it? Well, we use the delete keyword. Really simple syntax for delete. Delete from table. So select from, insert into, update this, delete from. So delete from table. What is the table that we actually want to delete the rows from? And optionally, which rows to match to delete. So another where clause, which rows come out that we will delete out of the database. Again, if we just do delete from table, if I just do delete from pet, everything goes, nothing matches, everything matches, sorry. Or we can put where queries in, we can put logic predicates in, and we can limit what goes on. So let's have a look. So we're back in our pet table, and we have D'Artagnan and Harry, so we're up to pet 109 at the end, and Harry sadly escaped. So he's no longer our pet, he flew out the window, last seen chatting pieces of 8 and going down the high street. So we want to delete him from our database. How can we delete Harry the bird? ID 109. Well, the syntax hopefully is fairly straightforward. Delete from pet, so delete from the pet table. We put a where clause in, we only want to delete one row, where pet ID equals 109. And again, you'll see why we're using pet ID rather than the name. That's what we're doing to delete it. So delete from pet, where pet ID equals 109. We run that query, one row is affected, and poor old Harry is gone from our data systems to be removed forever. In the real world, we're quite cautious about deleting data. Often, we don't actually delete stuff. What we do is we have something like a deleted flag or a column or something like that. If you delete your Facebook account, you don't actually delete your Facebook account. Mark Zuckerberg never lets go of your data forever. They'll hold on to it. If you delete my staff account, if I leave and I am deleted from the system, I almost certainly won't actually be deleted. All that will happen is a row will be updated to show that I'm deleted. But this is how we actually delete data. I've had enough. I've got these rows in the database. I've copied them over. I've archived them. This person has gone. I want to delete these entries within the database. So delete from pet, where pet ID equals 109, matches the primary key 109, and just deletes that row entirely. The where clauses are, as I mentioned, totally interchangeable. It's the same where format that we use for select, as we use for update, as we use for insert. How can we delete all the pets whose names end in anion? Delete from pet, where pet name like, %anion. So here we are, we're using our textual match. We're using like, which means find a string that's like it. We use %, which is the wildcard. So we're saying delete from pet, where any name has anything at the start and ends with anion. And then poor old Dogtanion is gone from the data as well. How can we delete all the pets? There's been a terrible, terrible accident. I don't want to talk about it, but I have no pets anymore. How do we delete all the pets? Well, as you might guess, delete from pet. We have no where clause. What happens when you have no where clause? All of the rows match. If we selected everything, we get everything. If we update without a where clause, we'll update everything. If we delete without a where clause, we delete everything. So delete from pets, empty set. All of the pets are gone. They are deleted, and off they go. It was a terrible day. So you need to be really careful with where. Very, very, very careful, especially when you're doing updates and deletes. It's really, really easy to mess up a where clause, especially when you have a complicated one with lots of brackets in. You can accidentally overmatch, or you could accidentally undermatch and then think you've updated everyone, whereas in fact you haven't. So it's important to be really, really careful. In a select, the worst case that happens is we don't get all the data. But when we do an update or a delete, we're actually deleting database when we can break the database. And it happens quite a lot. You see a lot of ITSM, IT service management failures, when people run an update and they fail to put the where clause in properly, and so they accidentally delete all the customers, or they accidentally update everyone, and they do this and they do that. So it's quite common to do that. So what I would suggest is what I call a cautious workflow. If I'm doing a delete or an update operation and it's sensitive, I will always do a select first. Because remember, the where clause works the same for all of them. So if I've built a where clause and I'm happy and it's sort of 15 lines long, well, the first thing I'll do before executing a delete is I will do a select first to get an idea. So we want to delete pet. We want to delete one pet, ID equals 123. So our where clause is where pet ID equals 123. Well, the first thing I'd probably do is I'd say select pet ID as count pet ID as X from pets, where pet ID is 123. So I've run the same where clause. We have the same where clause at the end that we're using, but we're going to get a count on. That allows us to know how many records we're going to delete, and we can then prompt the user, are you sure you want to delete X pets? If I want to delete one pet and I click delete and it suddenly says, are you sure you want to delete 25 pets? I know that I've made a mistake and I can back out of it before I then actually run the delete query with the same where clause. Right, that is a logical place for us to finish, and it's